Okay, to start this unit, we're going to basically take a quick review of a couple things that you learned back in Algebra 1 regarding the coordinate plane. We're going to start with the distance formula. And you may recall the distance formula a little bit from your Algebra 1 course. That allows us, it's a formula that allows us to find the distance between 2 points on a coordinate plane. So if we look at the coordinate plane, we can see point A and point B, and of course we can represent those with an X and a Y coordinate. Now, to make them different, we use these little subscripts of 1 and 2, so we can say X1 is different than X2, and that keeps them a little bit separate for us. Now, if you remember back to the Pythagorean theorem, if we can make a right triangle out of something, we can find the distance of one particular side and then the distance of another particular side. And if we put those two sides in the Pythagorean theorem, that would give us the distance of the hypotenuse. And basically, that distance of the hypotenuse is the distance that we're looking for. So if we keep the Pythagorean theorem basically in terms of x's and y's, you can see that we get this d squared equals x2 minus x1 plus y2 minus y1 squared. And then when we take the square root of both sides, we then have the distance formula. So this would be a very important formula for you to remember. It is something that is used on the ACT a lot. And of course, if you can't remember the distance formula, you could simply use the Pythagorean theorem by making a right triangle if necessary. Now, let's take a quick look at a distance formula problem. So if we look at example 1, it says find the distance between -2, 5 and 3, -1. And if you notice, we don't have a coordinate plane here with it being graphed, so we could either go that route. We could simply come up with a coordinate plane and go -2, 5, somewhere around there, and 3, -1. And we could simply, if I could draw straight, that would be great. We could simply visually see it in that regard. But what we're going to do here is we're going to just work on using the distance formula appropriately. And so if we have -2, we can make this our x1, and of course 3 would be our x2. So we're going to have x2 minus x1, so 3 minus a -2, and then we're going to square that whole thing. And then of course we're going to have a y1 and a y2. Now the important thing here is making sure that your x1 and your y1 are together and your x2 and your y2 are together. And it really doesn't matter which one you subtract first or which one you designate the 1 or the 2, long as you keep the order straight. And if we go through the distance formula, we can either keep it in exact terms, square root of 61, or we can approximate it with a calculator. So just for a little practice, a little review of Algebra 1 distance formula, go ahead and stop the video at this point and work sample problem number 1 for me. Okay, so if we start here, and if I say 2 is x1 and -5 is x2, and I'll make this one y1 and y2, this gives me my values that we need. Now, a good habit to get into is to go ahead and write the square root symbol or the radical symbol with every single step. If you get in the habit of just writing it once and then not doing that for every single step, you can make mistakes at the end by forgetting not to add it back. So we're going to start with x2, -5, minus x1, which is 2, and then we're going to square that, plus -1 minus, in this case it's a -4, so I have to put that -4 in parentheses, and of course we're going to square that whole thing as well. Notice here I'm going to start off by rewriting the square root symbol to give myself a make sure that I don't lose that. So -5 and -2 is -7 squared, and then we have -1 plus 4, which is going to be a positive 3, and then don't forget we have to square that as well. D equals, and again, the radical, negative 7 squared, and it's important that we use parentheses so that we get the appropriate sign. So negative 7 squared is 49. 3 squared is 9. And then D is going to equal the square root of 58. Now, we could either leave that in exact terms, or I could simply put that into my calculator and round it off to 7.62. Okay, so that's a basic example of the distance formula. Quick review from Algebra 1, and the distance formula will have some relevant meaning when we get into our conic sections unit.